To proceed further, now we will see diagnostics in vehicle control unit and domain controllers. Now this is a total different ball game. Diagnostics in high voltage is different. Diagnostics in charger is different. Now we will see diagnostics in vehicle control unit and domain controllers. Now diagnostics in vehicle control unit and domain controllers is central in managing, coordinating, and safeguarding the entire electric vehicle system. Okay, as you know, vehicle control unit is the brain of the electric vehicle. Now these components serve as central orchestrators, integrating multiple subsystems such as powertrain, battery, charging, thermal ADAS, and body electronics. Now, given their critical role in the system coordination, diagnostics in these controllers must be comprehensive, fail-safe, standard compliant, and robust against software and communication faults. Now, what are the VCU and domain controllers? What is meant by VCU? Let's briefly touch upon the VCU before we talk about the exact diagnostics on the VCU. Now, when it comes to VCU, a central controller managing core vehicle functions in EVs interfaces a central managing core vehicle functions in the EVs, and it interfaces with battery management systems. It interfaces with inverter, onboard charger, HVAC means heating, ventilation, air conditioning, brake ECU, transmission, if any, etc. So various verticals in the automobile are directly controlled with the help of vehicle control unit. All right, just like our hands, limbs, the entire body is controlled by the brain. Vehicle control unit controls the controls this controls the various parts of the vehicle. And just for information, I have a full-fledged course on vehicle control unit in Udemy. So in case you are interested, you are most welcome to do it. You can just type my name, Vamsi Palem, and you will see the concerned session or training course. Now it also executes the drive coordination, torque arbitration, state transitions, charging management, and diagnostics. Now when it comes to domain controllers used in zonal or domain-based EV architectures, example powertrain domain controller, body domain controller, and may take over functions from traditional ECUs, offering higher computation, integration, and service-oriented architecture. So also it worked closely with VCU and vehicle control unit in software defined vehicle architectures. So these are the in brief roles of vehicle control unit. Now when it comes to diagnostic objectives, well, naturally first is safety, to prevent unsafe operation during logic, actuation, and communication faults. Okay, so this is the uh, uh, first and foremost objective. Next is reliability, detect and handle degraded system behaviors, and example sensor drift, software errors. Next is interoperability, ensure valid communication across ECUs, sensors, and actuators. Now when it comes to compliance, it has to support the OBD, it has to support the UDS, ISO 26262, and cyber security diagnostics. Now, when it comes to predictive maintenance, enable prognostics through monitoring and subsystem performance. Now, I already explained very clearly about what is prognostics. Prognostics is nothing but future of diagnostics. Now, when it comes to key diagnostic functions in VCU and domain controllers, first is first is system health monitoring, and next is when it comes to system health monitoring, subsystem available checks is the first thing that need to be done. So subsystems like BMS, inverter, motor controller, OBC status polling, and also missing the heartbeat signals. These are all the various things that come under subsystem availability checks. Now, second thing which comes under system health monitoring is system power mode transition diagnostics, cranking, drive, charging, sleep transitions. So these are all the various kinds of power mode transition, and falls in wake up logic or sleep management. Okay, this also comes under the purview of system power mode transition diagnostics. Now coming to the second key diagnostic function in VCU and domain controller, It is sensor and actuator diagnostics. Now, when it comes to sensor plausibility checks, redundant sensors compared, example, accelerator pedal sensors, range, rate of charge, freeze detection. Okay, so checking the plausibility of the sensor is a very important part of the sensor and actuator diagnostics. And when it comes to actuator, command response monitoring. The thing is torque request sent, motor response expected, brake torque commands including verification via wheel speeds. Now, when it comes to communication diagnostics, we spoke about in the previous thing we spoke about two verticals that come under the diagnostics. Now we are going to see the communication diagnostics, the CAN, LIN, FlexRay or Ethernet monitoring, timeouts, CRC errors, bus off conditions, and next is message counter and alive supervision, consistency checks for rolling counters in safety critical messages. And now when it comes to diagnostic communication, fault response to invalid missing diagnostic requests, and inter-domain gateway diagnostics. Now faults in service oriented architecture interfaces. Now faults in service oriented architecture interfaces. Now when it comes next is the next vertical is powertrain and torque arbitration diagnostics. So in this we are going to check the sanity of the torque request, whether torque request is genuine or not. So why is this important? It prevents the incorrect acceleration or regeneration torque. That is the reason the torque request must be as accurate as possible. And also it checks against the entire vehicle state, gear, brake, status, etc. All right. Now coming to the drive inhibit conditions. So what are the various conditions that inhibit the driving capacity? First is charger connected. Whether when charger is connected, it should not drive. Whether when door is open, it should not drive. When the parking brake is on, it should not drive. And also torque coordination errors. Torque coordination error conflicts between regenerative and friction braking. All right. Now coming to the software and execution diagnostics. First is the watchdog timer monitoring and detects software freezes or logic lockup. Now coming to the stack overflow memory diagnostics, self checks on the heap, stack or flash regions, scheduler overrun detection, ensures all control tasks meet real-time deadlines. All right. So all these things come under the purview of software and execution diagnostics. And last but not the least, application of health monitoring. So when it comes to application of health monitoring, internal task status flags, logic faults. Okay, so these are all the various diagnostics that are happening in the vehicle controlling unit. Now again, you must have understood a particular pattern. For every vertical, there is something called functional safety. And when it comes to functional safety of the vehicle control unit, asset partitioning monitoring, ISO isolation cross checks between safety critical and non-safety functions. Okay, now when it comes to end-to-end protection, CRC plus counter monitoring between paired ECU, VCU to battery management system. And when it comes to mode management faults, discrepancy between requested and actual safety state. For example, limp mode. Limp mode is a important mode management fault. Now, when it comes to OBD, UDS fault detection and logging, first is DTC storage and diagnostic trouble code stored in non-volatile memory as per ISO 14229. And when it comes to freeze frame and snapshot data, it captures the time stamped sensor actuator data on the fault occurrence. Okay, I clearly explained what I mean by freeze frame. This has to be clearly monitored. All right, and also the mill activation, malfunction indicator light, especially in hybrid EVs and regulatory markets. So it has to monitor if mill activation is working accurately or not. Also, when it comes to performance and thermal diagnostics, the thermal monitoring and tracks overheating trends in powertrain, electronics, and cabin. Now, when it comes to performance degradation, the speed, acceleration, delivery versus driver request. It may suggest derating or early maintenance. Okay, it may suggest derating or early maintenance. All right, so all these things come under the purview of performance and thermal diagnostics. Now let's see some sample DTCs for VCUs and domain controllers. Okay, for every vertical or for every division, we are talking about the DTCs. So even for VCU, we will see some respective corresponding DTCs. Now, when it comes to first DTC U0100, lost communication with ECM VCU. Okay, whenever communication is lost with ECM or VCU, this is the DTC that pops up. And next is P0606 VCU processor fault. If there is a fault in the VCU processor microprocessor, then this is the DTC that comes out. Next is P2100 means throttle actuator circuit open. U0416 invalid data from ESP ABS controller, and P0A08 DC-DC converter status fault detected via DCU, and also P1A1F powertrain mode selection error. And these are the DTCUs, and now we are going to see the diagnostic test methods. After DTCs, we will see the diagnostic test methods. The first is startup self-test executed during the power on memory, software and sensors. And when it comes to periodic monitoring, health supervision during runtime, example task overruns, bus errors, and event-based monitoring triggered on the subsystem request or specific conditions. Now, when it comes to diagnostic requests, external scan tools initiate specific tests, and when it comes to hill testing, simulates fault conditions in controlled environment. Okay, so these are the various types of diagnostic test methods. Now, coming to functional safety and cyber security, first is when it comes to functional safety, ISO 26262 is the standard, and usually for VCU, because it is a very critical part, ASIL C or ASIL D is often required. And also, it's a must ensure fail operational or fail silent design. Now, when it comes to ISO SAE 21434, which is a cyber security standard, first is it secures the diagnostic access. It also authentication of the diagnostic sessions and prevention of unauthorized reprogramming or spoofing. So these are all the things that are ensured by the standard SAE 21434. So when it comes to tools for development and diagnostics, what are the various tools for development and diagnostics? First is Vector Cano and Canalizer. This takes care of the network analysis and diagnostic simulation. And next comes the ETAS Inca, calibration and fault injection. DSpace, National Instruments, PXI. This is a hill simulation platform. And OBD diagnostic tool, scan tools for production service. Now, when it comes to cyber security test suites for secure diagnostic protocol validation, okay, so this cyber test security test suites are very state-of-art tools. Okay, they are very latestly developed tools. So to conclude, we will touch upon the summary. So lot of for VCU also, we take care of the system integration, sensor actuator, communication, software execution, functional safety, OBD, UDS compliance and security. All right, and the description I have clearly mentioned here for system integration, availability of subsystems and mode coordination. And when it comes to sensor actuator, plausibility, signal rate, command mismatch, the actual working in very crude language, when it comes to sensor and actuator, you check the working of the accurate working of the sensor. And when it comes to communication, CAN timeout, signal loss, and gateway error. These are the major communication errors that may happen during the operation of the vehicle. Now, when it comes to software execution, watchdog, memory scheduler, logic health. Now, when it comes to functional safety, end-to-end protection, ASIL fault handling, and when it comes to OBD, UDS compliance, DTC logging and UDS service support. Okay, so security, when it comes to cyber security, it ensures the secure diagnostic access and message authentication. So these are all the ways or all the various angles in which the diagnostics are taking care of the vehicle control unit. Alright, hope all of you got a very clear cut overview about the importance of the vehicle control unit. Thank you.